So that's what we're going to do. We're just going to go over our 2 homework assignments, and then we will start the new section tomorrow. So the first one that we had was square root of 128. That is 64 and 2. 64 is a perfect square. 8 squared is 64. So I know I pull the 8 out in front, and then it's the square root of 2. So it's 8 roots of 2. That kind of ruins the surprise for number 3, because that was just the square root of 64, which is 8. Number 5, you're going to find that it's going to be best if you look for perfect squares. So I'm going to break this down to 16 and 2. And by doing that, now I can see that square root of 16 is 4. So 4 comes out in front, and the 2 is left inside. Keeping with that same theme, if I broke 18 down to 9 and 2, 9 is a perfect square, so that's 3 and 3. 3 comes out in front. You're left with 2 inside the root. Now if I had broken that down to something else, 6 and 3, and then break 6 down to 3 and 2, it gives me the same answer. I have a pair of 3's that comes out in front, and there's only 1 2, so it stays inside. So no matter what you break it down to, you're going to get the same answer, but if you look for a perfect root first, it makes it much simpler. 288 breaks down to 144 and 2. 144 is just 12 squared, so this would be 12 times the square root of 2. Any questions on those first ones? Okay, move on to number 11. Number 11 is the square root of 252. So when I look at this one, I can't think of anything that goes into 252. It's a perfect square, so I'm going to break it down. Break it down to 2 and 126. I still don't see anything that's real nice or anything. So I'm going to break this down to 2 and 63. 63 will break down to 9 and 7. 9's a perfect square, so I know that's going to be a 3 out in front. I have a pair of 2's, so a 2 comes out in front, and then this 7 is all alone inside the root. So that gives me 6 roots of 7. Number 13, the square root of 54. That breaks down to 9 and 6. That's obviously a perfect square. So it's 3 times the square root of 6. If we break 6 down, that's 3 and 2. So those are by themselves, and it's not a perfect square. Number 15, got to figure out what multiplies to give us 343. I don't even know what that would be off the top of my head. I know 3 doesn't go into it. The 7 would go into it. It would be 7 and 49. 49 is a perfect square. So that just breaks down to 7 and 7. I have a 7 that comes out in front from the pair, and a 7 that stays inside. So this is just 7 root 7. Number 17, 200 breaks down to 2 and 100. 100 is a perfect square. That's 10 times 10. So 10 comes out in front, and the 2 stays inside because it's by itself. Last one of these. 98 breaks down to 49 and 2. 49 is a perfect square, 7 and 7. So that would just be 7 times the square root of 2. Any questions on those ones? All right, let's move on to our next assignment, which was these problems. So we didn't have to do number 2. Some of you did it anyways. I'll show you how to do it, even if you didn't do it already. All right. First thing we should address is the usage of photomath. I mean, I get it. You might be struggling with this and you don't understand it. So you take out your phone and you scan the problem and it shows you how to do it. That's not really going to help you to learn it. It's a good way to check your answers, but they also do things differently than we do it. And so the first thing that photomath does on these is it tries to reduce those roots by doing 8 over 12 back inside a single square root, reducing that to 2 over 3, and then going from there. So as soon as I see that on your homework assignments, I know that you use photomath to do it. Again, good idea to check your problems, check your work. I have no problem with that. But the whole point of actually doing this stuff is to learn it. If you plan on taking any math higher than this, you're probably going to need that stuff. So cut out using photomath. First thing we tried to do was simplify this. So if I simplify 8, 8 breaks down to 4 and 2. That brings it 2 out in front with the 6. So that's 12 root 2. Then in the denominator, I need to break the 12 down. 12 breaks down to 4 and 3. 4 is 2 and 2. 2 comes out in front with the 5. It gives us 10 square roots of 3. Now I can reduce this right now. It gives me 6 root 2 over 5 root 3. Just divided both the top and bottom by 2 to get that. Now I have to rationalize my denominator, which means I multiply by the square root of 3. On the top, that's going to give me 6 root 6. And on the bottom, that's 5 times 3, which is 15. If I look at my numbers that are not under the roots, I can simplify those by dividing both of those by 3. That gives me 2 root 6 over 5. And that's your final answer for that. Number 2, I said you didn't have to do it, but in case you did try to do it, I need to multiply by the square root of 21 to rationalize that denominator. So what that means now is I distribute 21, square root of 21 to both terms on the top. So it's going to give me 2 times square root of 7 times square root of 21 minus 5 times the square root of 5 times the square root of 21 all over, and then our roots cancel. We're left with 4 times 21, so that would be 84 in our denominator. on the top, I can now simplify this. The reason that I left it pulled out is that I know that 21 breaks down to 3 and 7. So now I'm going to have a pair of 7s that comes out in front here. So I have a 7 here and a 7 from this one. So it's going to be 14 times the square root of 3 minus 5. And then think about breaking 21 down. That breaks down to 3 and 7. 3 times 7 times 5 doesn't do anything for us. So it's going to be times the square root of 105. And this is all over 84. And that's your final answer. Can't really do anything else with that. All right, number 3. Simplify the top first. 8 breaks down to 4 and 2. Square root of 4 is 2. So that gives me a 2 that comes out in front. I'll actually do the steps here. 8 breaks down to 4 and 2. And that's 2 and 2. So I have 4 times 2 from this 2 coming out in front. And then a square root of 2 left inside. It's all over the square root of 10. Rationalize the denominator. So multiply by square root of 10 on top and bottom. It gives me 8 times the square root of 20 over 10. I can break the 20 down. That's going to break down to 4 and 5. 4 simplifies to 2 and 2. So it gives me 8 times 2 times root 5 over 10. So that's 16 root 5 over 10. And I can simplify that to 8 root 5 over 5. Number 4. Square root of 4 is 2. So this is just 20 over root 10. Rationalize your denominator. It gives me 20 root 10 over 10. 20 divided by 10 is 2. So that's just 2 root 10. Any questions on those 4? All right, we're going to move on. Number 5. I have n squared equals negative 54. In order to solve this, I have to take the square root of both sides. It gives me n equals, if it's the square root of the negative, and I comes out in front, and I can break down my 54. 54 breaks down to 9 and 6, and then 3 and 3. 3 comes out in front with the I, and then times the square root of 6. Now this is the way that we have always written it. This is what I saw in some of your homeworks last week. Plus and minus 3 root 6 I. Does anybody know why we don't write it like that? It's because if I get sloppy or careless with this and I just scribble in, this is completely different than this. So when Photomath puts the I behind the square root, it's hard to tell whether the I is under the square root or not. So leave it out. Don't do it that way. Put the I in front of the root with the number. That way there's never any confusion. If you put the I behind the root, and I think that the root is going over the I, I'm going to mark it wrong on your test and quiz. Just because it's wrong. The I should come out in front. Take the square root of both sides here. Gives me x plus and minus. It's a negative, so I know there's going to be an I. 32 breaks down to 16 and 2. 16 is a perfect square. 4 comes out in front. There's only 1, 2 left. It stays inside the root, and you're done. Number 7, start by adding the 2 over. It gives me k squared equals 49. Take the square root of both sides. There's no negative here, so there's no I. K equals plus and minus 7. Number 8, start by dividing by 100. It gives me n squared equals 1 over 100. Take the square root of both sides. When you take the square root of a fraction, that's the same as taking the square root of the top divided by the square root of the bottom. Square root of the top is just 1. Square root of the bottom is 10. So it's plus and minus 1/10. Number 9, add the 4 over. Gives me 2n squared equals 126. Divide by 2, n squared equals 63. Take the square root of both sides. I get n equals, take the 63 down to 9 and 7. 9 is a perfect square. So 3 and 3. 3 comes out in front, square root of 7, and then it's plus and minus. Also, no need to break this up. I saw a lot of this. N equals 3 root 7, n equals negative 3 root 7. No need for it. Just leave it as plus and minus. So that's the same exact thing. Last one, number 10. We start by adding the 10 over. That gives us 10n squared equals negative 92. Divide by 10. It gives us n squared equals negative 92 over 10. Take the square root of both sides. I have a negative in here. It tells me there's going to be an I. Break 92 down. That breaks down to 2 and 46. 46 breaks down to 2 and 23. 2 comes out in front. We have 2i from the negative. Root 23 over the square root of 10. Last step is to rationalize the denominator. Multiply by root 10 on top and bottom. Gives me plus and minus 2i root 230. 23 doesn't break down anymore. 10 would break down to 5 and 2. None of those numbers repeat, so I'm done. Over 10. Last step here is to reduce the 2 and 10. It's plus and minus I root 230 over 5. Any questions on those? If you don't have any questions, you are free to go. Tomorrow we will pick up with complex numbers, and we'll start there.